All right, let's get started. This is SaMi video. I'm Olivia. We're doing the AMC 10 or AMC 8, 2020. And yeah, let's get started. So Aunt Anna is 42 years old. So we'll say A is 42. Caitlin is 5 years younger than Brianna. So Caitlin is Brianna minus 5. Brianna is half as old as Aunt Anna. So Anna over 2 is Brianna, which we can just turn into A equals 2B. So those two are the same thing, right? So how old is Caitlin? Well, to find that out, we can start with what we have. So we know what A is. A is 42. So we can plug that into our third equation to solve for B. So instead of A equals 2B, we can use 42 equals 2B. Dividing both sides of the equation by 2 gives us 21 equals B. And now we know that Brianna is 21. Now we can use our second equation to figure out what C is. C equals B minus 5. B is 21. So C is 21 minus 5. 21 minus 5 is 16. So Caitlin is 16 years old. All right. Which of these numbers is less than its reciprocal? So a reciprocal is 1 over the number. So in this case, we would have the reciprocal of 2, for example. 2 is the same as 2 over 1. So reciprocal would flip the numerator and denominator. So 2 over 1 becomes 1 over 2. So that's the reciprocal of 2 is 1/2. So is 2 less than 1/2? It is not. So E is out. D, 1 over 1. Reciprocal, switch numerator and denominator, still 1 over 1. So it's the same. It doesn't change. It's not greater than or less than. C, 0 is the same as 0 over 1. Reciprocal becomes 1 over 0. Anything over 0, if there's a 0 in the denominator of a fraction, that is undefined. It's not a real number, right? So if 0 is on the bottom, that's not a number, so it doesn't work. Okay, -1. -1 over 1 becomes 1 over -1. That is the same as -1, so it stays the same. It doesn't change. Okay, last one. Even though we know it's the answer, let's just double check to make sure. So -2 over 1 goes into -1 over 2. So which is less, -2 or -1/2? Well, -2 is more negative than -1/2. So the more negative something is, the less it is, right? So since -2 is more negative, it is less than its reciprocal, which is less negative. So that means that is our answer. How many whole numbers lie on the interval between 5/3 and 2 pi? So what's the closest whole number to 5/3? The one that's bigger, ideally, because we want it to be between those numbers, and 5/3 is the smaller of the two. So 5 over 3, the next closest whole number is 6 over 3, which is 2, right? So 5/3 on our number line. Next off, we have 2. Okay, and 2 pi. Pi is 3.14 something, so pretty close to 3, right? And 2 pi is 6.28, right? Which is just bigger than 6. So here's 2 pi on our number line, and here's 6, right? So how many whole numbers are between 5/3 and 2 pi? Well, we see 2 and 6 there. We've also got, obviously, 3, 4, 5, right? Because those are between 2 and 6. So that's these 5 whole numbers. 2, 3, 4, 5, 6 are between 5/3 and 2 pi. So our answer is 5. Let's do some guessing and checking. Oh, and just a reminder, if you want to read out the full problem before I do the video, that's a good idea. And also try to solve it on your own before I start solving it. Okay, so in 1960, we want our graph to be 5%, right? So that's this line, 1960. And we see in graph A, 1960 is closer to the 10% here, right, than it is to 5%. So that's not right. B, it doesn't look like it's quite in the middle between 0 and 10, right? It's not like, ooh, that's pretty bad. It's not like in the middle. It's closer to the top. So we'll wait on that, but it doesn't seem right. C looks like it's in the middle. D, we're not sure. E, we're not sure. So we've eliminated A. 1970, we want 8%. So that eliminates B, right? Because in 1970, it's at 10%. C is still in. D is not in, right? Because that's at 10% in 1970. And E is still in. Okay. Now in 1980, we want 15%. So that's here. Ooh, graph C looks like it's closer to between 20 and 30%. So that is not, 15 is not between 20 and 30, so we can eliminate that. E, on the other hand, is between 10 and 20 in 1980. So that could be 15. And then just to be sure, in 1990, we want 30%, and we can see that that's the case for graph E, which is our answer. All right. Each principal of Lincoln High School serves exactly one 3-year term. What is the maximum number of principals the school could have during an 8-year period? Okay, so let's draw out an 8-year period. I'm just going to say 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we want as many principals as possible in this time, right? Okay, so something that people might assume is that, oh, the first principal needs to start in this first year and then go this entire time. But actually, what we can say is, well, what if, well, and if we do it like that, then we would have 1, 2, 3 principals, right? And then that last guy would keep going for the next year after we stop paying attention. So, but if we don't start with the same year a principal starts, we could, like, for example, have a principal who's ending his term on the first year we're counting. And then another principal, maybe she's going these 3 years, another one goes these 3 years, and then a last one keeps going on, starting in that 8th year. So if we did it like that, where the first principal has 2 years worth of time, and then we start counting, that actually gives us 1, 2, 3, 4 principals. And that's how we would maximize that, right? Because we've got the case where the principal starts the first year, where the principal ends the first year. Our last case is the first principal has its middle term in the middle year, right? Then we have something like this, right? And that also involves 3 principals. So our maximum, because we have all 3 cases accounted for now, is 4 principals in that 8-year time. All right, so we've got a square, and we want to find the area of the shaded L shape. Okay, well, looking at that L, I actually think it might be easier if we broke it down into 2 rectangles and a square, right? You see those 2 rectangles and a square, and we know this is a 3, this is a 3, this is a 1, this is a 1. All right, and if we take the areas of each of these shapes separately and we add them together, that'll give us the total area of the L shape, right? So here we have a 3 by 1 rectangle that has area 3. Another 3 by 1 rectangle has area 3. And then what about the square? What are its dimensions? Well, we know that for the rectangle that has the area 3, its sides look like this: 3, 1, 1, 3. And this 1 right here, that side, that is part of the square, right? It's one of the faces of the square. So that means the square has face 1. And for the same reason, this face is also 1, because you can do the same with the top rectangle. So that square has area 1, right? Adding those together to get the total area of the L shape, that'll give us an area of 7. We want to know the minimum of the set of the possible 3 products, right? So out of 3 numbers picked, out of that set of numbers, what 3 would you multiply together and you would get the smallest number, right? So because we have negative numbers, we want to multiply them together and get another negative number. So for example, we could have like -8 times -6 times -4. That'll give us a negative answer. And we can actually make a little chart to see like when you would get negative and when you would get a positive answer. So for that, we would have a positive times a positive makes a positive. Positive times a negative makes a negative. Negative times positive is negative. And negative times negative is positive, right? And so for the case of 3, I encourage you to try like what's the case with 3 numbers. But either way, so if we're multiplying 3 numbers together, we either need 3 negative numbers or 1 negative number to get a product that is negative, right? So let's say we have 3 negative numbers. There's only one way to do that with 8, 6, and 4. And multiplying those together, we're going to get negative 192, right? So that is -8, -6, and -4. Okay, can we do any better? Well, we could take some positive numbers, right? 1 negative and 2 positives. So in that case, to maximize our product, we would take -8, 5, and 7, right? The two biggest positives times the biggest negative, the number that's the most negative. So 5 times 7 times -8, that gets you negative 280, right? So that's negative 8 times 5 times 7. And so far, that's our best answer. That's the one that's the least out of our two cases so far. Can we do any better? Well, no, we can see pretty clearly that we can't, because we took the out of like one negative number and two positive numbers, we found the one that would have the biggest absolute value, right? 8, 5, and 7. You can't do better than 5 and 7 for positives if you have the negative 8. And there's only one way where you have three negative numbers, negative 8, negative 6, and negative 4. So in order to get negative 336, we'd have to use numbers that either won't be negative in this system or aren't in this system. So that doesn't work. So our answer is B, negative 280. So we want to know that we need to add up the total number of dots that we can't see, right? So we know a dice has sides 1 through 6. So on the top dice, what numbers do we not see? Well, those would be numbers 4, 5, and 6, right? Because you can see 1, 2, 3. The middle dice, we can see 4 and 6, so we can't see 1, 2, 3, or 5. And on the bottom dice, we see 1 and 5, so you can't see 2, 3, 4, or 6. Adding up all of these numbers, these are all of the faces we can't see. It's a lot of addition. The top one adds up to 15. Middle one adds up to 11. Bottom one adds up to 15. In total, that's going to give us 41. Answer choice D, and that's our answer. And I encourage you, while you see me working through it, before I give a solution, and keep in mind there could be multiple solutions, try it on your own. See if you can tackle the problem, even if you're not entirely sure how to do it. Just like a start is better than, nothing. And it's okay sometimes if you have absolutely no idea where to start. Like, that's why we do this. Okay, so we need to figure out some number that's 2 to the m that fits into the across box, and some number that's 5 to the n down. So basically, they're asking us for powers of 2 and powers of 5, right? So what are some 3-digit, right? Because it needs 3-digit powers of 2. Well, let's count some powers of 2, right? We got 2, 4, 8, 16. Notice I'm just multiplying by 2. 32, 64, and now we get to our 3-digit numbers. 128, 256, and 512. Right? Multiplying by 2 again gives 1024, which is not a 3-digit number. So those are our 3-digit power of 2s. Okay, what about powers of 5? So that's 5 times 5 is 25. Multiplying that by 5 again, that gives us 625. No, that gives us 125. 125, and the next one is 625. I got ahead of myself there. So we want something that, so either downward, we need the power of 5. So it's either 625 or 125, right? So downward, that's either 625 or 125. And either way, whether it's 6 or a 1, that means our middle number, the one in the middle, is a 2, right? So that means our power of 2 needs to have a 2 in the hundreds place, right? And the only one that has that out of our 3 is 256, right? So whether it's 125 or 625 in the down position, the 256 is going to be our power of 2, and the number in the box, right, that's a 6. That's our answer. Okay, onward. Number 10. So, we know that Shea is 120% of what she originally was, right? Originally, she was 100% of her original height, plus a 20%, 100 plus 20. So we got Shea is 120%, which is 60 inches, right? So we got 60 is 120% of her original height. Okay, and we want to know how tall in inches Ara is now. And we know that Ara grew half as many inches as Shea. So if we find out how many inches Shea grew, then we can figure out how many inches Ara grew from that, right? So if 60 is 120% of Shea's original height, what is her original height? That would be what's 100% of her original height, right? Okay, so we can do some cross multiplying, right? 60 times 100 divided by 120, that's cross multiplying. Or what we could do is we could say, okay, 120, that's 20%, right? That's 1/5. So 60, that's 6/5, right? Of some number. And we want to find 5/5, right? So if 60 is 6/5, we could divide it by 5. 60 divided by 5 is 12. Right? Yeah, 12 times 6. Or 12 times 5, right? Because we want to find 5/5, not 6/5. So 12 times 5 is... Okay, wait, I'm getting this confused. Pretend I didn't do that. So if we have 6/5, we want to find 5/5. So what's 1/5 of that? So we can divide it by 6 to find 1/5, right? Divided by 6, that's 10. 10 is 1/5, right? So 5/5 would be this times 5. 10 times 5 is 50. So she was 50 inches tall, and now she's 60 inches tall. So Shea grew 10 inches. So we know Ara grew half as much, so that means Ara grew 5 inches. And if they both started at 50 inches tall, we have 50 plus 5. That means Ara grew 55. Ara is now 55 inches tall. Cool. So we want numbers between 10 and 50 where the units digit is, the number is divisible by its units digit. So like, for example, we have 64 is divisible by 4, right? So 64's units digit is 4, 64 is divided by 4, so that meets the property. Okay, well, why don't we start by focusing on some cases? What about the case where some number has the units digit 1? So like, what are our numbers with units digit 1? 11, 21, 31, 41. Those are the ones between 10 and 50. Are all of these numbers divisible by 1? They are, right? Because every number is divisible by 1, except for 0. That's a little complicated. Every positive number is divided, or positive and negative, not 0. Yeah, every whole number is divisible by 1, right? So 11, 21, 31, and 41 meet that requirement. Okay, what about numbers that end in 2? That would be 12, 22, 32, 42. Well, all of these numbers are even, right? They end in 2, so that means they must be divisible by 2, right? You can divide it by 2, you get 6, 11, and on and on. Okay, what about 3? There we have 13, 23, 33, and 43. Is 13 divisible by 3? Nope. Is 23? Also no. 33 is, though, so we can count in 33. 43 isn't either. All right. 4s. 14 divisible by 4? Nope. 24? Yes, it is. 34 isn't, and 44 is. Okay. What about 5s? 15, 25, 35, 45. Anything ending in 5 is divisible by 5. If you don't already know that, that's something good to remember. Ends in 5 is divisible by 5. Okay? 6, 16, 26, 36, 46. The only thing divisible by 6 there is 36. Okay, 7, 17, 27, 37, 47. None of those are divisible by 7. 8, 18, 28, 38, 48. 48 is divisible by 8, but none of the other ones. And lastly, 19, 29, 39, 49. None of those are divisible by 9, so we are done. Okay, how many numbers do we have here? 4, 8, 9. I'm counting 17. Always good to double check just to be sure. Yep, so that's 17 numbers have that property. Cool. All right, number 12. Okay, we want the smallest number of blocks that are needed to build a wall that's 7 feet high. So that means we're going to need 7 layers of blocks. And we want to use as few blocks as possible, right? So smallest number of blocks means we want to use the biggest number of blocks possible because they take up more space, so we don't need as many of them, right? So let's say the bottom one uses only the big blocks, right? So those are 2 feet wide, or 2 feet long, and we want a wall that's 100 feet long. So that means 100 divided by 2, we'll need 50 blocks for the bottom layer, right? 50 of these. Okay. The next part of the wall is going to need it's going to need 2 1x1 blocks, right? Because we can't just put another block like this on top. We need to stagger it, like is in the drawing, right? See how it's staggered? So that means we're going to need to start with a 1x1, and we're going to need to end with 1. So that means that's going to add 1 extra block, right? So instead of 50 on the bottom, or 50, the second row is going to have 51. And then for the third row, we can go back to how the first row was, right? It's going to be the exact same, so we have another 50. And this is a 7-layered wall, right? So that means we have a total of 4 layers that have 50 bricks or blocks and 3 layers that have 51 blocks, right? So that's 50 times 4 makes 200. 51 times 3 makes 153. Adding those together, we have 353 blocks needed to build the wall. I'm just going to draw it a little bigger just so we have more room. We know that ACT is the same as ATC. So that means this angle is the same as this angle. I'm just going to put a little line here so that they're the same. We also know that CAT is 36. So that top angle is 36. Okay? TR bisects ATC. So that means that this angle here is split in half by TR. Right? That line splits it in half. And we want to find CRT. So that would be this angle here. That's our mystery angle. Okay, so let's fill in what we can learn from this. So in our original big triangle, we want to figure out what those 2 equal angles are. What are ACT and ATC? Well, a triangle is going to add up to 180 degrees, and we already have one side of 36. So that means the other 2 sides, they need to add up to 144, right? And we know that those 2 angles are the same. So we can divide 144 by 2 to figure out what those angles are. So that would be 72. Okay, so here's a 72-degree angle. Well, the bisected angle is also going to need to be divisible in half, because half of the angle is on one side of the line and the other half is on the other side, right? 72 divided by 2 makes 36. So here we have a 36-degree angle. Here's another 36-degree angle. Cool. Okay, now, finally, we want to find our mystery angle, and we see that it's one angle of a triangle with side 72 and a side of 36, right? So, adding that up, that triangle already has 108 degrees accounted for, so that missing angle is going to be the rest of the triangle, right? The 180 minus the 108 that are already being used. So that is 72 degrees. Cool. So that is, we want to find the units digit of that sum. Now, I know some of you might be thinking, and I'm going to have to warn you, don't actually calculate these by hand, because that is going to take you a very long time, and it's not going to be very fun. So, we want a shortcut, or something that makes it at least a little easier, right? So, what we can do is we can say, okay, let's ignore the 10, right? In 19, the 1 isn't going to contribute to the units digit, right? Because we need to do 19 times 19. Really, the units digit is just the 9 times 9 part. So it'll end in 1, right? So let's start finding powers of 9 to see what it ends in, right? So 9 to the 1, that's going to end in 9, right? It's just 9. 9 squared, that's going to end in 1, right? 9 times 9 is 81. There we go. 9 cubed, we can just multiply the 1 from 9 squared by 9. That's going to end in 9. And then we can keep going on, but we see that there's a pattern, right? It goes 9, 1, 9, 1. Okay, so what's the units digit of 19 to the 19th going to be? Because right here we have the first power, second power, third power. But we can notice a pattern. So when it's odd, so 9 to the first and 9 cubed, they both end in 9, right? So the odds are ending in 9. The evens, 9 squared and 9 to the fourth, they're ending in 1. Ooh, okay. So 19 to the 19 is odd. So that's going to end in our odd power, which is 9. There we go. Halfway done. Okay, what about 99 to the 99th power? Well, that also ends in 9. Wait a second. So when you square it, 99 times 99, the only thing that's contributing to the units digit is the 9 times 9, right? 9 times 9 is 81, and then you can continue on with the multiplication. But our units digit is set now, right? It's 1. So 99 to the first, that ends in 9. 99 squared, that's going to end in 1, right? Like we just found out. So it's the same pattern as the 19. And what's better is the even and odd power still applies, right? 99 to the first ends in 9, 99 squared ends in 1, evens and odds preserved. So 99 to the 99th power, 99 is odd, and we know when it's odd, it's going to end in 9. Okay, so now we have two numbers ending in 9. When you add them together, the units digit is going to be 8, right? 9 plus 9 makes 18. So adding them together, we have a final units digit of 8. So here we've got a triangle, and we want to find the perimeter. So we see that there are 3 separate triangles, but really we want to find this perimeter, right, of them all added together. So we know they're equilateral, so all of the sides are the same length. And we know AB is 4, right? So here's a 4, and BC is also 4, right, because of the equilateral triangle. Okay, what about the other side of the triangle? Well, we know that point D and G are midpoints of the triangles that they touch, right? So that means halfway along this triangle is where this next smallest triangle starts, right? So halfway means the side is cut in half. So instead of 4, we have 2 and 2. But we're adding the perimeter. So the bottom 2, right, this isn't contributing to the perimeter. That's the inside of the triangle. So we only want this 2, right, for this side right here. Okay, and because that equilateral triangle, the next smallest one here, has side length of 2, right, because it takes up 2 here, all of these other sides are also 2. So here's the side of 2, and, okay, here's the tricky part. So in this upside down triangle, the second one, we've got a 2 and a 2, and you would think this next one's a 2, 2. 2, 2. But you'd be right. But also, don't forget, we've got a little smaller triangle attached to it, right? So instead of a 2 and a 2, we've got a 1 and a smaller one. But this inside one doesn't count towards the perimeter, right? So that shows that the smallest equilateral triangle has side length 1. So adding these all together, here's our 3 triangles. We've got a 4, 2 here, 2 here, 1 here, 1 here, 1 here. Okay, what do we get if we add that all together? I'm counting 15, and that's our answer. So we've got a rectangular backyard. And to walk 1,000 meters, you can walk the length of it 25 times, right? So 25 times the length, that equals 1,000 meters. Okay, so because we know that, we can solve for the length. Okay, we can divide both sides of this equation by 25, and we get L equals 40. Cool, that already tells us something. So here's our 40. Okay, or you could walk the perimeter 10 times and get 1,000 meters. So 10 times the perimeter, which is 2 length plus 2 width, so that's our 80, right, for the 40 and the 40, plus 2 times the width, right? We get 2 widths. Make up the perimeter. And that is 1,000, right? Okay, solving for our W, we divide both sides of the equation by 10. 80 plus 2 times W makes 100. Subtract both sides by 80. 2W is 20. Okay, what's W then? Divide 2W by 2 and 20 by 2, and we get W equals 10. So that means our perimeter is made up of 10s and 40s, and we want to find the area. So that's 10 times 40, which is 400. So basically, we want to, whenever you have two numbers, and we'll just call them A and B, when you see that symbol between them, you need to do this to them. You need to square A and divide it by B, right? So let's start with our equation. So PEMDAS, order of operations, we do it to 1 and 2 first, right? So instead of A symbol B, we've got 1 symbol 2, right? And in that case, we're going to do A squared, and A in this case is 1. So 1 squared is 1, and divides it by B, which is 2. So inside there, we've got 1/2. and then we continue on. Now we need to symbol that with a 3. Okay, 1/2 symbol 3. 1/2 is our a, so we square 1/2. 1/2 times 1/2 is 1/4, and divide it by b. b is 3. And that's going to give us 1/12, right? 1/12. So now we have 1/12 and then minus our other stuff. Okay, order of operations, we need to do what's inside the innermost parentheses. That's 2 symbol 3. So 2 is our a, we square 2, 4, and we divide it by b, which is 3. So now we have 4/3. And now finally, this turns into 4/3. We have 1 symbol 4/3. So 1 is our a, we square our a, and divide it by 4/3. And that turns into 3/4. Cool. So now what we have is 1/12 minus 3/4. What does that equal? Well, to subtract, we need common denominators. 1/12 minus 9/12. That gives us negative 8/12, and we can simplify that to be negative 2/3. Good job. All right. Let me delete that. Okay, now we've got 2 quadrilaterals, and we need to figure out which of these statements are true. And these statements have to do with their area and perimeter. So let's figure stuff out. So we can start by saying that their perimeter, well, okay, let's start by saying the distance between 2 dots that are next to each other, right? We're just going to call that 1, just because it's easy, right? Let's just say it's 1. Okay, so area-wise, we see our top quadrilateral, the one that looks like this. Well, it's taking up half of a square, right? Plus another half of a square. So we're going to say that its area, right, half plus a half, that has area 1, right? Okay, what about the bottom one? The one that has a little bit of a funnier shape. So we see the bottom one is also half of a square. But what about the top one? What's the area of that? Well, we've got a triangle. Base 1, height is also 1, right? So area of that triangle, base times height divided by 2, 1 times 1 divided by 2, that is 1/2. Ooh, so it's also half of a square. So they both have area 1, right? Adding up the top and the bottom of the top quadrilateral, 1/2 and a half makes 1, and the bottom one, 1/2 and a half also makes 1. So their areas are the same. So we can cross out A and B. Okay, now we need to figure out their perimeters. So we can look at number 1. So we see wherever there's a straight line, that is 1, right? We already determined that. What about the tilted one? Well, that's part of a triangle that has side length 1, right? So we're basically solving for this hypotenuse, the long side of the triangle. We can do that with Pythagorean theorem. A squared plus b squared is c squared. Here, 1 squared plus 1 squared equals our hypotenuse squared. So 1 squared plus 1 squared is 2. 2 equals our hypotenuse squared. So our hypotenuse is the square root of 2. So that means this quadrilateral has a side square root of 2 and square root of 2. Okay, what about for the other quadrilateral? Well, that one has a side length of 1. We can see it has 2 sides that are the square root of 2. So far, 3 of the 4 sides are the same, right? It has 2 sides that are square root of 2 and 1 side that's 1, which matches up with our first quadrilateral. What about that last side, the kind of longer side? Well, we see that's actually the part of a triangle with side length 1, right? Here's the 1, and side length 2. Here's the 2. And figuring out that last side, we do 1 squared plus 2 squared. 1 plus 4 makes 5. And so that side is the square root of 5, right? Pythagorean theorem. Take the square root of 5, we get the square root of 5. So now to figure out which quadrilateral is bigger, we just need to figure out what's bigger, 1 or the square root of 5. And to do that, we can compare the numbers when you square them, right? 1 squared is 1, root 5 times root 5 is 5, and that 5 is bigger than the 1. So that means our second quadrilateral is actually the bigger one, or has the bigger perimeter. So which one shows that? perimeter of 1 is less than perimeter of 2, option choice E, that is our answer. So we've got a semicircle, and its radius is 5, so its area is going to be, let's see this top semicircle, radius squared times pi, 5 times 5 is 25 pi, it's only half of a semicircle though, so it's 25 pi over 2, right? Our rectangle is, well, this part here can be thought of as a rectangle with 2 quarter circles taken out of it, right? We don't want this part to it. It has quarter circles taken out. So what does our rectangle look like? Well, we know halfway through is 5, 5, 5, 5. So our rectangle is 10 by 5. So it has area 50. What about the 2 quarter circles? Well, putting them together would be a semicircle. So basically, we need to take out a semicircle, which we already found from our first part, has area 25 pi over 2. So the total area of our entire shape is 50 minus 25 pi over 2 plus the 25 pi over 2 from the top, right? This 25 pi over 2 minus the rectangle that has this part taken, or plus the rectangle that has that part taken out. So 25 pi over 2 minus 25 pi over 2, these parts cancel, and we're left with a rectangle, or a shape with area 50. Nice. All right, next one. So for this one, we have quarters, nickels, dimes, pennies. We'll keep track of them. We know we have one of each type at least. So that's one of each. And they add up to 102 cents. Well, or $1.02. So because there's the 2 at the end, the 2 cents, we know that there has to be at least one more penny, right? Because nothing else is going to give the 1 more cent. And then just as a refresher, quarter is 25 cents, nickel is 5 cents, dime is 10 cents, penny is 1 cent. And if you don't have this memorized, it's a good thing to review. Okay? So adding this up, what we have here, that's 5 coins, and they add up to 42 cents, right? So we still have 60 cents that are unaccounted for, and we have 4 more coins to use. So how can we make 60 cents with 4 coins? Well, we're going to need a quarter, right? Because the next biggest thing, the dime, 4 dimes, isn't going to add up to 60 cents. So if we add in another quarter, that's going to be 35 cents now that are unaccounted for. Okay? We have 3 coins now to make up 35 cents. I think that'd be easiest to do. We need another quarter, right? Minus another 25, add another quarter to our tally. Now we have 10 cents and 2 coins. And the only way that's going to happen is with nickels, right? 2 nickels will make 10 cents. So that's our 2 more coins. How many dimes are there? Well, we see there's only 1 dime. That is our answer. Okay, so we want to figure out the probability that Ephraim, sorry if I mispronounced that, gets the same number of heads as Kiko. So there's 2 cases, right? Either Kiko gets 1 head or Kiko gets 0 heads, right? So if Kiko gets 1 head, what's the probability that Ephraim also gets 1 head? Well, let's see. He can get either heads and tails, tails and heads, 2 tails, or 2 heads. So out of these 4 cases, only there's 2 ways where he gets 1 head, right? Heads, tails, and then tails, heads. So, because when you toss a coin, there's an equal chance of getting heads or tails, these 4 probabilities each have an equal chance of occurring, right? You're as likely to get a tail and then a head as you are to get a tail and then a tail. So, there's 2 ways, 2 out of 4 ways, where when Kiko gets 1 head, E also gets 1 head. So 2 out of 4, that's the same as a 50% chance. That's 1/2. Okay, what if Kiko gets 0 heads? Well, there's the same choices for E, right? And how many ways does he get 0 heads? Well, there's only 1 way that happens, right? When there's 2 tails. So there's a 1 in 4 chance that when this happens, they get the same number of heads. Okay, so now we've got 2 separate probabilities. what are the chances of each of them happening? So what's the chance that Kiko gets a head, and what's the chance that she gets a tail? Well, 50-50, right? She doesn't have a bigger chance of getting a head than a tail. So there's a 50% chance, so 1/2, that Kiko gets a head, and then from there we know it's also a 50% chance that E also gets a head. On the other side, there's a 50% chance that she gets a tail, and from there we know there's a 1 in 4 chance that E also gets no heads or 2 tails. So adding those together, 1/2 times 1/2 makes a 1 in 4 chance, and on our other one, 1/2 times 1/4 gives a 1 in 8 chance. Adding that together, that's a 3 in 8 chance of that happening. So to start, let's find the surface area of the original cube. So remember, surface area, that's going to be the sum of the area of each face of the cube. So it means the face of one cube, it's 2 by 2, right? That's 4. So the area of a cube is 4 in this case. And since all faces of the cube have the same area, that's going to be 6 of them. 4 times 6. So the original surface area was 24. Okay, what about our new surface area? So we still have that same original bottom cube, right? Except for now we've lost a 1 by 1 space on the top, right? The top has less surface area than it did before because it is being covered. So we've got this 24 from the original minus 1 because of that top face, and then plus what's showing of the smaller cube, right? So we've got 5, right? Because that smaller cube has 5 faces showing, except for the one on the bottom. That part's being covered by the bigger cube. So that's 5 faces with area 1. So that's plus another 5. So 24 minus 1 plus 5. So now our new surface area is 28. And we want to find the percent increase from 24 to 28, right? So basically it's saying we've increased by 4. And 4 is what percent of 24? Okay. So 4 is to 24 as some number is to 100. And we can cross multiply here. So 400 divided by 24, that is 1. (24) divided by 160. Other way around, 160 divided by 24. That is 6. And some change. So 16 2/3, which is closest to 17%. And that is our answer.